In this lecture, I will share law of conservation of linear momentum and its proof. First of all, let's understand what is the definition of law of conservation of momentum. According to this law, if no external force acts on a system, no external force. This is a condition. If no external force acts on a system, then total momentum of the system does not change with time. Means total momentum remains constant. So this is called law of conservation of momentum. Let me again repeat. If no external force acts on a system, then total linear momentum of the system remains constant. Now we have to prove this law of conservation of linear momentum. For proving this law, let us consider two bodies, body 1 and body 2, which are moving with some velocities. Suppose u1 vector and u2 vector. Suppose these two bodies collide with each other and then get separated. Suppose after collision of the two bodies, their velocities become v1 vector and v2 vector. So this is the situation before collision and this is the situation after collision. By taking this example, we can prove law of conservation of linear momentum. Suppose during collision, body 1 experiences force F1 vector and body 2 experiences a force F2 vector. According to Newton's third law of motion, these two forces F1 vector and F2 vector will be equal in magnitude and opposite in direction. So we can write F1 vector is equal to minus F2 vector. So this can give us F1 vector plus F2 vector is equal to 0. Let me call it equation number 1. Now suppose the collision takes place for a very short interval of time, delta t. Let us suppose. If I multiply equation number 1 by this short interval of time, I will get F1 vector plus F2 vector multiplied with delta t is equal to 0. This will give us F1 vector into delta t plus F2 vector into delta t equal to 0. Let me call it equation number 2. According to impulse momentum theorem, impulse of a force acting on a body is equal to change in momentum of the body. So using this for body 1, I can write F1 vector multiplied with delta t is equal to, this is nothing but impulse acting on first body due to force F1 for the time of collision, that is delta t, force into time interval, equal to change in momentum. What is change in momentum of first body? Initially its momentum is m1 u1 vector. After collision, its momentum becomes m1 v1 vector. So change in momentum is m1 v1 vector minus m1 u1 vector. Similarly, for second body number 2, impulse can be written as f2 vector multiplied with the time equal to change in momentum of second body. For this second body, I can write m2 v2 vector minus m2 u2 vector. m1 is mass of first body, m2 is mass of second body. Let me call this equation number 3 and this as equation number 4. I will put these values from 3 and 4 in equation number 2. So using equation number 3 and equation number 4 in equation number 2, we can write m1 v1 vector minus m1 u1 vector. This is value of impulse acting on first body plus m2 v2 vector minus m2 u2 vector impulse on second body equal to 0. After simplification, I can write m1 v1 vector plus m2 v2 vector is equal to m1 u1 vector plus m2 u2 vector. So this last expression represents total momentum of the system of two bodies after collision, because momentum means mass into velocity, equal to total momentum of the system before collision. So I can write total momentum after collision equal to total momentum before collision. That means total momentum of the system of two bodies does not change during collision of the bodies unless some external force acts on the system. When no external force is acting, due to internal forces, momentum of the system does not change. Hence the proof for law of conservation of linear momentum.